Good evening. I welcome you to the next NCERT problem solving session. In this session, I am taking up further questions from exercise 3.2 on matrices. The question today what we are going to discuss are kind of important short answer questions from board examination point of view. Okay, given f of x, a matrix is given as f of x. To be very precise, this is question number 13 of exercise 3.2. Given f of x as cos of x, I am writing column 1. So sin x followed by 0. I am writing column 2, negative sin x. Cos of x and 0. Column 3 given as 0, 0 and 1. The students are asked to prove that the product f of x into f of y gives f of x plus y. So this is the question, and we are going to do the left hand side, arrive at right hand side of the equation. When I say left side, multiplying f of x with f of y, you need to get f of y first, which means effectively replacing the variable x with y. So let me get what is f of y. So from every given term in the matrix, go on replacing x with y, so it becomes cos y. In first row, you continue negative sin y followed by 0. Sin y in second row, cos y and 0. Third row is mere number 0, 0 and 1. So therefore, multiplying f of x, f of y together means multiplying two 3 by 3 matrices together. And when you multiply the 3 by 3 matrices together, the result is also a 3 by 3 matrix. So let us go ahead. Cos x, negative sin x, 0, sin of x, cos of x, 0, 0, 0, 1 in third row. The second matrix when I write, it is cos y, negative sin y, second row sin y, cos of y, 0, followed by 0, 0 and 1. Well, as I told you, the product is also a 3 by 3 matrix, and if students have watched the previous video of multiplying the matrices, how to assign the row and the order of a column and the pairing of the elements suitably, okay, you will be familiar with the process. So when I first get ready to find the element what I have to write in position 1, 1, I consider the row 1 of first matrix and column 1 of the second matrix, and I take the appropriate elements as pairs, which means I get cos x and cos y. Let me complete the product cos x cos y. Then the second element along the row, second element along the column, which means I get minus sin x and sin y. Let me complete it. The product is negative of sin x sin y, followed by the third elements in the order, which is 0 times 0. I need not write plus 0. Okay, let us move on. Next, I move on to column 2. So when I fill position 1, 2, which means I have to take row 1 from first matrix, column 2 from second matrix. So focus on the elements which are to be paired. Cos x to be paired with negative sin y, negative sin x to be paired with cos y, 0 with 0. Let us fill the product of the corresponding terms. Cos x negative sin y, so the result is negative cos x sin y. And once again it is negative sin x cos y. That is done. And the last pair of elements is 0 times 0, which I need not write because adding a 0 does not make any difference. When I proceed to fulfill the first row, third column, take third column of second matrix, focus on the elements that are to be paired, which is cos x and 0, negative sin x and 0, 0 with 1. So you find every product ends in 0. So the result is 0. Cos x times 0 also, sin x times 0 also, 0 here, 1 here. Let us move on to the second row, which means I have to do second row and take column 1 and properly consider the pairs, which means sin x and cos y is the first pair. Let me complete the product. Completing the product, I get sin x times cos y. And second element along the row, second element along the column, properly paired, it is cos x sin y plus cos x sin y. And then you know it is 0 with 0. The product 0 I need not add, doesn't make any difference. Moving on to column 2, yes, sin x is matching with the minus sin y. So minus of sin x and sin y. Next is cos x paired with cos y. So it is positive cos x cos y followed by the 0. So 0 with the 0, second row, third column, 0, again 0, again 0. Coming to position 3, 1. We take third row from first matrix and complete the product by taking every column first, second and third from the second matrix. Let us do it. It is 0, again 0, again 0. So you find the 3 zeros are to be added. The same thing here, the 3 zeros are to be added. But when I do the third row and third column, you can see 0 paired with a 0, 0 paired with a 0, 1 paired with a 1. So result is 0 plus 0 plus 1. So that is the result. Now students will find this one interesting because every element becomes a trigonometry identity by itself. Are you noticing that it is cos x cos y minus sin x sin y is a class 11 identity for cos of x plus y. Cos of x plus y gives cos x cos y minus of sin x sin y. So I want the students to be reminded of these identities, and sin of x plus y is sin x cos y plus cos x sin y. So if you carefully analyze, these two identities keep repeating. These two identities keep repeating. In case it is a bit troublesome, probably for the second element of first row, take negative common. Once you take negative common, you are left with sin x cos y, what we found for the identity, and plus cos x sin y, the second term in the identity, yes, but negative is there, so you can take negative common. So this is going to become negative times sin of x plus y. First term without any negative or change of sign, you can take it as cos of x plus y. So I am going to write the product. I am writing the LHS. Don't forget, the LHS is you have taken f of x and f of y. We multiplied them together, and as a result now what we get is cos of x plus y, then followed by negative sign common for the identity of sine of x plus y, and third element of row 1 is 0. Second row, first column, you can find the exact identity, the RHS of sine of x plus y is found there. So I am writing the exact identity for sine of x plus y, followed by cos of x plus y, which is cos x cos y minus sin x sin y. So you can find this is exactly reproduced, okay, without any change or confusion. And then there is a 0 followed by 0, 0 and 1. After writing this step, I request students to compare what is the f of x and what is this you got. Cos x is replaced with cos of x plus y, which means the variable x is replaced with x plus y. Variable x is replaced with x plus y in second element also. Negative sin x has become negative of sine of x plus y. Similarly, second row there are two elements. Sin x has been replaced with sine of x plus y. Second row, second column, cos x has also been replaced with cos of x plus y. Other elements zeros and ones remain zeros and ones. So you can directly mention this is f of x plus y, and that is the RHS. We started with the LHS of the expression, what the students need to prove, and we ended up in the RHS. So this is a popular 4-mark question of CBSE, and I have taken up one more question from this same exercise, which is also a potential 4-mark question. We can discuss it now. To be very precise, it is technically question number 15 of exercise 3.2. If matrix A contains these elements, I am writing column 1 first, column 2 next, and column 3 at last. Okay, you are asked to find, nothing to prove, simply find a square minus of 5a plus 6i. So you find the question has 3 terms, 3 matrix terms. The first matrix term is a squared, which means matrix A multiplied with matrix A. 5A, it is the scalar 5 that multiplies matrix A. 6I, the types of matrices when we described in our session 1, we were discussing the types of matrices, the diagonal, the scalar and identity matrix. So here is where you are now getting exposed to the identity matrix. Identity matrix is of order 3 is, it is going to be 1 0 0, 0 1 0 and 0 0 1. So these are the 3 terms you have to put together and evaluate the result. Let us do term by term and then put them together. So I am going to evaluate a square first, which means a multiplied by same matrix A once again. So let me write the elements. So what I have done, I have reproduced the elements of matrix A, multiply with the same matrix once again. Students can get ready to fill the product matrix. Now I want to give a simple task. Students can observe here in the previous question when we multiplied, you saw we multiplied the elements pairwise. That was not numbers, it was not made of numbers, they were rather trigonometry functions. So we could not know the value of cos x cos y, we wrote it as it is as cos x cos y. And the sum we could not immediately evaluate in mind. Okay. But here the students can do so in mind. So when I do 1 1, which means evaluating the product of row 1 and column 1 of second matrix, which means once the students focus on the right pair of elements, you can easily write the product. It is 2 times 2. Go through the process of multiplication, grasp it and write the result here. 2 times 2, you know in mind it's 4, plus 0 multiplied by anything 0 and plus 1. So 1 is added to the 4. If students are finding the process a bit cumbersome, you are welcome. You are welcome to write it as 2 plus 0 plus 1. There is absolutely no harm in doing it. You are welcome. I am moving on to the column 2. Have the pairs in mind. 2 paired with 0, 0 paired with 1 does not give any number, it's 0. So 0 and 0. 1 and minus 1 gives a non-zero result. So the answer is minus 1. When I do the same thing with column 3, what do I get? The pairs are 2 and 1, 0 and 3, 1 and 0. So whenever you get pairing with 0, the result is 0 and you know only 2 into 1 is left over. That way it becomes easy for you to write the end result. What about the second row? In second row, starting with second row, column 1, we proceed column by column. Let us do it. Have the products in mind. 2 paired with 2, 1 paired with 2, 3 paired with 1. All are non-zero entities. All are non-zeros. Be careful. 2 into 2 is 4. 1 into 2. Therefore, 4 added to 2, 6. 6 added to 3 into 1. 6 added to 3 into 1 gives 6 plus 3, 9. Let me write here. Okay. Third row, second row, now moving on to second column of second matrix. Have the pairings in mind. 2 with 0, 1 with 1, minus 3 and 1. 2 with 0 is 0 plus 1 minus 3. So 1 minus 3. You can calculate, write the end result. Second row, third column. So when we move on to second row, third column, have the pairs in mind. 2 into 1, 1 into 3, 3 times 0. So 0 you can ignore. You can add 2 into 1 and 1 into 3. So 2 plus 3 only and it gives result 5. Is that fine? We will move on to third row, columns 1, 2 and 3 in the same order as we did completion of rows 1 and 2. Have the pairs in mind. It is 1 and 2, minus 1 and 2 and 0. So the answer is going to be 0. Why? It is positive 1 into 2, then negative 1 into 2 and plus 0 into 1. What about third row, column 2? Have the pairs in mind. 1 paired with 0 gives 0, minus 1 and 1 gives a minus 1, 0 with minus 1 gives 0. Which means minus 1 and 1 gives a minus 1 only. The rest of the answers are zeros. And moving on to third column, we get pairs 1 into 1, negative 1 into 3 and 0 times 0. So it is 1 and minus 3 giving you the result negative 2 only. And remember, this is answer for a square. Remember, this is answer for a square. Shall we call it? We will call it a result 1. Okay. So carefully we can evaluate and complete the evaluation of all the three terms to sum it at the final result. What about 5 times a? So when I do 5 times a, it is a simple task of the scalar number 5 multiplying matrix A. Multiplying matrix A means multiplying each and every element of the A by scalar 5. So we can do that also, complete it within your mind. 5 multiplies every element. So 5 times of 2, 5 times of 0, 5 times of 1. Let us continue. 2 times of 5 and 1 multiplies 5 and 3 also is multiplied by 5, 15, and 1 into 5 minus 1 into 5 makes minus 5 and 0 in position 3, 3. Let us call it result 2. What about the third and the last term, 6 times I? It is 6 times of, I want you to carry in memory always I matrix of given order. Okay, let me just indicate what it is. It is 1, 0, 0 in row 1, 0, 1, 0 in row 2, and 0, 0, 1 in row 3. Now we are multiplying it with scalar 6. So it is going to be 6, 0, 0, 0, 6, 0, third row, 0, 0 and 6. Let me call the result 3. Now a squared negative 5a positive 6i, which means you have to take up result 1, subtract result 2, add result 3, and let us check out what it gives. What it gives, I am only going to replace the equation numbers with relevant matrices. Okay, so a square matrix, in your view, from your view, it is 5 minus 1 and 2 in row 1, 9 minus 2 and 5 in second row, 0, negative 1, negative 2 in third row. Then subtract 5a, result is already there, that is 10, 0, 5, 10, 5 and 15 in second row, 5 minus 5 and 0 in third row. You are going to add 6i. So it is 6, 0, 0, 0, 6 and 0, 0, 0 and 6. Now once you have written down all the matrices with proper signs in order, it is very easy to calculate the sum total. Okay, let us put the numbers, gather them. Well, let me do, I am not in a hurry to complete it all in mind. Okay, I am just writing the corresponding elements, which means position 1, 1, 1, 1, 1, 1, I am putting them all together in position 1, 1. So it's going to be 5 minus 10 plus 6. So let us write it, 5 minus 10 plus 6. And in column 2, let us gather the corresponding elements. Minus 1, 0, 0. I think students can comfortably ignore the zeros. Okay, so minus 1 and leave it. Minus 0 or plus 0, it's not going to add or alter this number. Let us move on to third column. It's going to be 2 minus of 5 plus 0. So I am writing 2 minus of 5 plus 0. I am ignoring because it doesn't alter the result. In second row, let me write, it is 9 minus 10 plus 0. I am ignoring, doesn't alter the result. Position 2, 2, let me write 9 negative 2 minus 2 minus of 5, but position 2 2 has a plus 6, and then the second row third column position, let me fill it, 5 minus 15. 0 does not alter, so I am not including it, I am ignoring it. Let us complete the third row. It is 0, okay. Let us not write 0 again. Minus of 5, okay, and plus 0, so let us not include. So the result is 0 minus of 5 plus 0. I am just omitting zeros and leaving it as minus 5. What about position third row second column? So it is starting with minus 1, yeah, and minus of minus 5. So this you have to be careful. It converts, the sign gets changed. So minus minus, and here the position is 0. So let us not write it. It need not be included here. What about the third row third position? It is negative 2, negative 0, and plus 6 and plus 6. So students, are we ready? Yeah, we are ready to write the answer. 5 plus 6 is 11 minus 10, it's going to be 1. Here minus 1, 2 minus 5, yeah, minus 3, 9 minus 10 again, and minus 1 minus 10. Students can check, it is a minus 2 minus 5, negative 7 plus 6. So it is negative 7 plus 6, leaving minus 1. 5 minus 15 makes minus 10. Then in third row it is minus 5, and 5 minus 1 or minus 1 plus 5 makes 4, and 6 minus 2 makes 4. So the answer for the expression a squared minus 5a plus 6i, it is 1 minus 1 minus 3 in row 1, minus 1 minus 1 minus 10 in row 2, minus 5 and 4 and 4 in row 3. Similar exercises you will find in board examination for any kind of prove that in question in 4 marks, okay, and even matrix multiplication involving large matrices, okay, with involving such kinds of functions can appear, okay. And in our next session we are going to solve statement questions on matrix multiplication. So statement questions on matrix multiplication, students can eagerly look forward. Okay, thank you. I'll meet you in the next problem solving session. Bye.